Question 1. Which of the following IP address ranges is not defined by RFC 1918 for private use? Option A, 10.0.0.0 to 10.255.255.255. Option B, 172.16.0.0 to 172.3, 1.255.255. Option C, 192.168.0.0 to 192.168.255.255. Option D, 169.254.0.0 to 169.254.255.255. The correct answer is 169.254.0.0 to 169.254.255.255. Here's the explanation. The ranges 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16 are the three blocks reserved for private use by RFC 1918. The 169.254.0.0/16 range is for automatic private IP addressing, APIPA, or link local addresses, used when a DHCP server is unavailable, and is not an RFC 1918 private range. Question 2. What is the primary characteristic that distinguishes private IP addresses from public IP addresses? Option A, private IP addresses are globally unique, while public IP addresses are reusable within different networks. Option B, private IP addresses are routable on the public internet, while public IP addresses are not. Option C, private IP addresses are used for internal communication and are not routable on the public internet, while public IP addresses are globally unique and internet routable. Option D, private IP addresses are assigned statically, while public IP addresses are always dynamic. The correct answer is private IP addresses are used for internal communication and are not routable on the public internet, while public IP addresses are globally unique and internet routable. Here's the explanation. This option correctly highlights the core difference. Private IPs are for internal, non-internet routable communication, and public IPs are globally unique and routable on the internet. Options A and B reverse these characteristics, and option D is incorrect regarding assignment types. Question 3. An application server in a private subnet needs to download software updates from the internet. Which networking component is typically used to enable this outbound internet access while keeping the server's private IP address hidden from inbound internet connections? Option A, Internet Gateway. Option B, Virtual Network Peering. Option C, Network Address Translation, NAT, Gateway. Option D, Public Load Balancer. The correct answer is Network Address Translation, NAT, Gateway. Here's the explanation. A NAT gateway allows instances in private subnets with only private IP addresses to initiate outbound connections to the internet. It translates the private source IP to its own public IP for outgoing traffic. An Internet Gateway, A, allows public IPs to access the internet. VNet peering, B, connects VNets. A public load balancer, D, distributes inbound traffic. Question 4. When an Azure Network Security Group, NSG, evaluates network traffic, how are its rules processed? Option A, all rules are evaluated simultaneously, and the most permissive rule takes precedence. Option B, rules are processed in random order, and the last rule evaluated determines the action. Option C, rules are processed by priority number, from lowest to highest, and the first matching rule's action is applied. Option D, Only inbound rules are processed, as outbound traffic is always allowed by default. The correct answer is, quote, rules are processed by priority number, from lowest to highest, and the first matching rules action is applied. Here's the explanation. NSG rules are processed sequentially based on their priority number, from lowest, highest priority, to highest, lowest priority. As soon as a rule matches the characteristics of the network traffic, its action, allow or deny, is immediately applied, and no further rules are evaluated for that specific packet. First match wins principle. Question 5. Every Azure Network Security Group, NSG, includes a set of default security rules. Which of the following is true about these default rules? Option A. They can be deleted or modified to customize security policies. Option B. They have the highest priority, lowest numerical values, and always take precedence. Option C. They ensure basic connectivity and an implicit deny for traffic not explicitly allowed by custom rules. Option D. They only apply to inbound traffic, not outbound. The correct answer is, quote, they ensure basic connectivity and an implicit deny for traffic not explicitly allowed by custom rules. Here's the explanation. Default NSG rules are immutable, cannot be deleted or modified, and have the lowest priority, highest numerical values, 65000, 65500. They act as a catch-all, ensuring basic connectivity, e.g. within VNet, and an implicit deny for any traffic not explicitly allowed by custom rules with higher priority. Question 6. If an Azure Virtual Machine, VM, has an NSG associated with its network interface, NIC, and another NSG associated with its subnet, what is the evaluation order for inbound traffic attempting to reach the VM? Option A. The NIC NSG rules are processed first, then the subnet NSG rules. Option B. The subnet NSG rules are processed first, then the NIC NSG rules. Option C. Only the NIC NSG rules are evaluated, as they are more specific. Option D. Only the subnet NSG rules are evaluated, as they apply broadly. The correct answer is, the subnet NSG rules are processed first, then the NIC NSG rules. Here's the explanation. For inbound traffic, if an NSG is associated with both the subnet and the NIC, the NSG associated with the subnet is evaluated first. If the traffic is allowed by the subnet NSG, then the NSG associated with the VM's network interface is evaluated. The traffic must be allowed by both NSGs to reach the VM. Thanks for watching. Please subscribe to my channel.